And now at this stage, let's test our model. We have used we've trained our model with this dot fit. Yeah, we've trained our model with this dot fit. So let's just test our model by using model dot predict. You can see can predict. Now I want to predict using S-test because S-test is the input, 20% of the inputs. We use 20% of the inputs. This is the input, bedroom and bathroom. 20% of this input is probably just one of this row. So we're using these values to test because we've used one to train our model. So we want to test with this. Then later we'll compare the y-test is the value for this price, which is this. So later we'll compare what we get for this S-test with the y-test. So let's run the code. Let's see what it will give us. My.predict S-test, sorry, capital letter S. So as you can see, this is the prediction it has given us. So let us store this predicted value inside a variable. You can call it ypred or something or anything you like. You can put anything you like. It's just a variable to store what has been done here, because we're using this variable in the next stage to evaluate our metrics. Evaluation is like trying to see what this has predicted and the actual value. Actual is this line of code. This is the row we're trying to work with now for our testing, right? We've used this first 4 row for our training, and this is the row we're using for our testing. So we use just these two to predict this price. We use the bedroom. If we have four bedrooms and 1 bathroom, what will likely be the price? So it will use the metric which has already been trained for from this initial training stage to use it to predict. So now we'll compare. Let's see if this is the actual price for this. We'll see if what our model gives us is close to this using our evaluation metrics. We can use at this stage we have already done the prediction here, and we've saved it inside this ypred. Our prediction has been done, and we saved the ypred. Now we want to evaluate our metrics, our model using an evaluation metric called mean squared error. Mean squared error is used, maybe we're trying to evaluate like a number or a regression kind of problem. But if we're trying to work on a classification problem, we use stuff like precision and recall and stuff like that for our predictions, for our evaluation, sorry. So at this stage, I'll be using a mean square error for my comparison. Let me break it down. I want to compare. This is what I predicted, not the actual. What I predicted here, I saved it inside ypred. The actual from this testing set is this 1141, which is this. It's called y-test. It's called y-test. Remember, this last row was used for testing because I defined 20% of the whole data set table for testing. And 20% of these 5 rows, 1, 2, 3, 4, 5, is just 1 row, which is probably this 1 row. And I used this as S-tests. These were used for my S-test, and this was y-test, which is actual. And this S-test was predicted and saved inside ypred, which is y prediction. It can be any variable. It can be ypred, it can be ypreds. This is a variable, a container. I have to say what's at the right side of the code. So I call this ypreds. And now I want to evaluate my metrics using mean square error that is to show if my predicted value and my actual value, what is the variation between them. So first thing, I call my mean square error. I'm just going to bring the code from my previous work because of time. I don't want to be writing out all the lines of code. So this is mean square error equal to y-test and ypred. Y-test, like I said initially, is the value of this price for in our testing set, testing row, which is this. Ypred is the already predicted value, which we predicted just now in the last stage. So now let's just bring out our mean square error value using a printing or a printout. It's a Python code to print out our mean squared error. So let's run the line of code. Now we've completed our evaluation. I've gotten our mean square error, which determines how well our model worked comparing our actual value and predicted value. So last line of code, which is this, is for just import job lib. The job lib is used to save our model. I want to save our model. You can see I've saved my model inside this my drive, inside this folder called tutorial, and I've named it house price model. I can name it house priced model, anything. Now in summary, I started my project by I linked to my data set. After linking to my data set, I did data preprocessing. This is linking and then trying to read my data set inside Google Colab. I did data processing, and data processing stage include very simple feature selection. I tried to select my features, try to define which one was input, which was output. Output is what I was trying to get to predict, while input is what values or ingredient will I be using to predict the output, which I use the number of bedrooms and number of bathrooms to predict the price of the house. After that, I did in my data processing, actually scaled it. I scaled to the table to make it like fine-tuning, make it better. After that, I splitted my data sets by doing splitting. This train test split tries to make us specify which of the data or the values of the tables I'll be using for training, or which will I be using for testing. You can see I specify test size as 20%, which means 20% of all the rows in the table will be used for testing, while 80% will be used for training. After that, what I did was simply to train my model, and training my model, I used model.fit to train it. I used a linear regression model for my training because it's a tabular data. So I used linear regression. Had it been working with probably an image folder or something, I would have used maybe another kind of method for training. So in this method, I could have also used dense neural network, but I choose to use linear regression for simplicity. After doing this training, the next thing I did was a very simple prediction of using this test set, which is 20% of our table values. As you can see, 20% might just be just one row. And this testing S-test specifies the inputs values from the testing sets or the testing row, which is just this bedroom and bathroom, just this particular 4 and 1. Why this Y test is the actual price, which is this 11410000. So that's what I did, and I saved this inside a variable called ypred because I needed to do an evaluation at the end of the project, an evaluation which I use mean squared error to compare this ypred, which was the prediction I did, and the y test, which is the actual value. This is the actual value from this testing row, because this is the row is for testing. So after doing that, using mean square error, I got this as my mean square error. So finally, I had to save this my project. I saved it using a name. This is a name I used to. I named it. I saved inside my Google Drive. You can save it anywhere. So thank you guys for watching my video. If you've learned a lot from this video, I would like you to like and subscribe to my channel. Once more, my name is Chidima Idono, aka Chidi.